Let me start. Uh, good morning and welcome to this lecture of electronics. And we are now starting with semester six. Hopefully, the portion of microcontrollers. And today, let us start. Let us begin with some of the introduction of microcontroller. So, in the last semester, I expect that you have studied about microprocessor. Right now, what is a microprocessor? If you recall that, so that will be far easy to understand microcontrollers as well. So, what is actually a microprocessor? So, microprocessor was actually a 8-bit microprocessor was able to process a 8-bit of data, and it was having a 16-bit of address lines, and it was working on plus 5 volt power supply. And the main important feature of 8085, which lagged him, or which was supposed to be the drawback, was the microprocessor was not having anything inside it. It was having only general purpose registers made up of semiconductors, and which were being used after it was being programmed, right? So that was the basic drawback of microprocessor, and this drawback was actually eliminated in microcontroller. So in microcontroller, the microcontroller itself is having, along with all registers and all data bus and everything, it is also having now the memory inbuilt inside it, which can be used for storing the programs. So in microprocessor, the memory was outside the microprocessor. It was on the kit, right? Whereas in microcontroller, the memory is now being placed inside the microcontroller itself, right? So that was the basic difference between that. Let us start with what I mean to say by that. Let me share my screen. I guess my screen is visible to you, and is it visible?
Yes,
Okay,
sir.
so is it visible for you all? So let me introduce myself. Myself, Dr. Andy Mishram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And today we are going to start with the topic of microcontroller. I guess a little bit of introduction to microprocessor. And yes, this is the IC that we use. 8051 is the IC of the microcontroller, which we are going to study throughout this. Am I audible? Hello? Am I audible?
Yes, sir.
Is my
Yes, sir. Yes.
okay?
Clearly.
Yes, sir.
Actually, it is not showing over there. Okay. So yeah, today we are going to study about the 8051 microcontroller. That is the number of that chip, IC chip 8051, and this is how it looks, which is shown on this. So it is made by Intel, and we'll study about the basic differences of 8051 and 8085 microprocessor, right? So 8051 microcontroller as well as 8085 microprocessor. So as you can see, what was actually a microprocessor consist of? So microprocessor was based on the CPU, sorry, external RAM, ROM, and input-output devices. That was input-output ports, and there was no internal RAM, or ROM, or input-output ports in the CPU itself, right? So we need to establish them, or say implement them on the kit on which the microprocessor was placed, right? So this was there, and then this is how it was being used, I guess. Okay, yeah. So this is how it was being seen when we mean to have a microprocessor. So microprocessor was having a CPU which was there, and inside it we were having some general purpose registers, address buses, and all, and the RAM, ROM, input output port, timer, serial common port, and everything was outside the microprocessor, right? So it was not built inside, and that was built on the motherboard, right? So I have shown you all the kits where we have done the program. and you were able to see that the microprocessor chip was on one side, whereas the other accessories which were required to use this microprocessor was built in on the kit itself, 8085 kit, right? So this was the basic block diagram of a general purpose microprocessor, where we were having a CPU 8085 on one side, and the other side it was being connected to the RAM, external ROM, and as well as external input output port. So we were using a mm, independent input output port IC, which was say the 8255 IC, right? So that was external, the CPU of the microprocessor. Then we were having a timer unit. We have used a crystal, using a crystal clock. We were done that. That was timer, and then we were having a serial common port, right? So serial common port was there, serial, and also we were having input output parallel port also. So through 8255 we were used to communicate to the external devices. So this was the basic structure of microprocessor 8085. And now, coming to the difference of this to the, say, microcontroller. So a microcontroller is now considered to be a smaller computer on a chip. On chip RAM means it is having internally inbuilt RAM, random access memory, as well as ROM. Then it is having input output ports which are inbuilt inside that particular chip itself, right? Even we are having a timer circuit inside it, but externally we will have to place the crystal. Then we are also having a serial controller. So everything is inbuilt inside that microcontroller chip, right? So it is smaller and compatible chip which can be used for different programming, different purposes. Now, the basic advantage of microprocessor was we were able to perform different sorts of programs in it, right? So we have to feed those programs and we have to run those programs, and we were using to try to execute those programs, right? So we used those microprocessor for those purpose, and it was very convenient for us to program the same microprocessor for different programs, right? So for different softwares, we can design over there, we can check it, and we can verify those programs whether they are working there or not properly. So this was the advantage of a microprocessor. But for a particular say project, for a particular result, what we were expected to do is we were supposed to use this microprocessor in that particular level, right? So for a particular say work, we were not able to use the complete microprocessor over there, right? So for that there was a basic need of developing a circuit which can be used for a particular reason or a particular project, right? So for that a particular software, a microcontroller is the base suitable chip. Now in here we are able to program this microcontroller chip for that particular say program, right? And that can be used for that. So actually it is a input output device which can be used for different purposes, right? Like a traffic controller signal, right? So a traffic control signal is a program software. Now here we are not supposed to use a microprocessor kit because it is very costly comparatively to this microcontroller chip, right? So so we can't use a microprocessor over there in the software that is being used in the traffic control. So what we are supposed to do, we are supposed to program a particular IC, and we can put that microcontroller chip in the place of a microprocessor for that particular purpose of using it as a software for traffic control, right? So this was the basic difference between the microprocessor and a microcontroller. Now looking at the block diagram of say the microcontroller. So in the single chip, as you are able to see over here, in a single chip, you are having a CPU, you are having a RAM, random access memory, you are having a ROM, read only memory, then we are having input output ports, then we are having a timer circuit inside it, Then also we are having a serial COM port, right? So we can have a serial communication port which can be used to transfer the data serially, and also we are able to input the data serially, so we can use it in all the forms, and this is completely integrated in only single chip, right? So that is how this microcontroller can be used for a specific reason or a specific purpose. So we need not have to use the whole kit, take that whole kit and use that for particular use. Rather than we can program this microcontroller for that particular programming or say specific purpose, and we can use that a small kit in the place of microprocessor. So this is the advantage of a microprocessor instead of microcontroller. And as you are able to see, this is all inbuilt inside that chip, right? So we'll be seeing in depth. We'll be studying this in depth in the coming chapters, coming lectures, where we are expected to learn more about the microcontroller. What is the basic block diagram of a microcontroller? How say how the RAM and memories are being spaced, how they are being used, how we can use different types of memory, what type of registers we are having in this microcontroller. So there is uh, say there are many more advancement and many more changes which were required in microprocessor are being done in this microcontroller chip, and now they are being placed inside this, right? So this was a very big discovery on that note, as far as microcontrollers are concerned. So we are going to study this in whole depth. So just to understand what is the basic difference between a microprocessor and microcontroller, we are seeing this normal block diagram of a single chip 8051 microcontroller, right? And to learn more about, say, the difference between the microcontroller and microprocessor, here we can distinctly differentiate between a microcontroller and a microprocessor. So in a microprocessor is a standalone, that is, it is a very small unit in which we are not having anything. And they are being connected by the database RAM, ROM, input, which are very separate to the CPU microprocessor. I request all to please mute your phones. Yes, somebody is, yeah. So microprocessor is having a CPU which is in a standalone type, RAM, ROM, input, output, timer, which are being separated from the CPU. Whereas in microcontroller, a single chip is consisting of a CPU, RAM, ROM, input, output, and timer are all on a single chip, right? So they are inbuilt inside, they are integrated inside the single chip. Now, designer can decide on the amount of ROM, RAM, and input output chips. Now, here that there is a flexibility that you can decide your own random access memory or say read only memory, and how much memory you require. You can change those memories, you can program those memories accordingly, and we can have input output ports that can be used specifically. But in microcontroller they are being fixed because they are inbuilt inside it, so we are not supposed to change those ports or say those amount of memories which are used. They are inside it, so we have to use they are going to be used whether you are using those or not. That is another issue, right? So we are having only uh, the memories which can't be changed. Then these microprocessors are very expensive as compared to the microcontrollers. Microcontrollers are very cheaper. Then we are having versatility, means we can do various types of programs in a microprocessor, whereas in microcontroller it is actually mean for a single purpose. I have already told you that if we need to use it for say a traffic signal, right? So we can use a microcontroller for that specific purpose, but we can't use we can't use say we can't use the microcontroller for another purpose. So for another purpose, we'll have to again program it for that purpose, and accordingly, we'll have to arrange the hardware of that, right? So the microcontroller is actually used for a single purpose. Then microprocessor is called as a general purpose also. So general purpose means every programs can be done in this microprocessor, right? But it's very difficult for a microcontroller to use for variety, right? So a particular microcontroller can be programmed for a particular reason. So that's why this is called as a special purpose microcontroller, right? Special purpose means for a simple one particular level. So this is the basic difference between, say, the microcontroller and a microprocessor. I guess you have understood this, and yeah. So the microprocessors or microcontrollers, which are based on the embedded systems. Embedded means which are being inculcated in a single chip, right? So this microcontrollers are called as the embedded system. Now this uh, special purpose computer system usually completely inside the device it controls. So it is already embedded inside that. And this has the specific requirements and performs predefined tasks. So it is programmed for a single purpose. Cost reduction as compared to general purpose processors, my microprocessor, and different design criteria means performance, reliability, availability, and safety. So we are having everything over there in over there. So I guess this much is enough for today, and we'll continue this in the coming classes. So these are some of the examples of embedded system. We are using this in car, where we are having the power window, power brake, and then we are having the power steering, right? And we are using airbags, and also nowadays we are using in-vehicle networking system. So everything is controlled by this microcontroller. These microcontrollers are designed or programmed for a special and say a particular purpose, right? So this is the best example of a microcontroller that we are being using in this. So I guess this much is enough for today, and I guess you have also understood what are the basic say differences between a microprocessor and a microcontroller. To start with, I guess this much is enough. So we'll be continuing this in the next lecture tomorrow at the same time. Uh, at the same time. So just uh, be attentive on that, and please make sure that you'll be regular in these classes. And if you have any queries, you can ask me on that. So we'll be stopping it here today. Yes, I will be uploading more videos of like this in the coming classes. So thank you very much for that. Please go through my YouTube channel, like, share, and subscribe my channel. Thank you very much. Have a nice time. Stay home, stay safe. Please take care of yourself. See you in the next class on this. Have a nice time. Thank you. Bye.
Bye, sir.